Sherloc stands for Structural Health Monitoring, Manufacturing, and Repair Technologies for Life Assessment of Composite Fuselage. The overall aim of Sherloc is to combine advanced structural health monitoring, SHM, and smart repair technologies with probabilistic design philosophy. Hence, to develop new maintenance concept to reduce direct operative costs without lowering operational safety of the fuselage. Sherloc is responsible for manufacturing 5 structural item demonstrators. They include 5-meter fuselage panel, window frame being manufactured by Cetim, floor beam, pressure bulkhead aft, and fittings.
Dans le cadre du projet Sherloc,
in the Sherloc project, there is a sub-project called Sherloc QSP, which consists in designing and manufacturing a thermoplastic composite window frame, which is tested according to the specification of a regional aircraft.
From a process and technology point of view, one of the objectives of the Sherloc QSP is to develop an edge-shaped part without overmolding. This point is a real technological progress for the transformation of thermoplastic composite parts.
One of the tasks of Cetim in the Sherloc project was to perform the sizing and detailed design of the window frame. The window frame is made of carbon PEEK, a material that is already well known by aircraft manufacturers. It was characterized for this project, particularly to feed interlaminar properties into the stress calculations. The frame is made from discontinuous U-shaped patches, which is an optimized shape to limit material weight from cutting into pre-consolidated plates.
The simulation of the manufacturing process helped us to save time during the development of the part. First, the forming simulation helped us to define the contour shape of each of the 8 patches that compose the part. In addition, the thermomechanical simulation of the part cooled in the mold allowed us to anticipate the spring-back phenomenon during the tool design.
Regarding the manufacturing tools, we can highlight 3 key points studied with Cetim. The provisional definition of spring-back effect, which is still a value that is not easily managed today. The development of features in the tooling that allow manufacturing an edge-shaped part without overmolding. And finally, the adaptation of the mold for the QSP process, which needs some specific features given the material constraints of carbon PEEK or PEC.
Regarding the manufacturing, the key point in this project is the precision. That is, the precision of patch cutting, the precision of positioning and assembly the different patches together to form the preform, and finally the precision of placement of the melted preform into the mold. It is the work done on the precision and the improvements made in the mold that allowed us to make a significant innovation in this project. The window frame is at net shape when it gets out from the manufacturing tool. The aeronautics sector must adapt to an increase in production rates, particularly for regional aircraft. Window frame is a recurrent part. It is in this context that the choice of manufacturing process was made for the QSP process. QSP process allows a reduction in manufacturing cycle time and a reduction in the amount of material used and low amount of scrap. The reduction of the material quantity is obtained by the use of patches that allow the orientation of the fibers and to adjust the thicknesses according to the stresses in the different segments of the part. This reduction in the material quantity used has the double interest to reduce the mass of the part and to reduce the total quantity of material required for manufacturing, which has a direct and significant impact on the final cost of the part.
The window frame is assembled onto the fuselage panel by adhesive bonding between epoxy and PEEK. The assembly of panel and frame will then be loaded to failure during static test in a picture frame fixture. It will be submitted to a global shear load, which will be mostly felt by the corners of the window.
We already have some experience in net shape technology, but through an available technology called overmolding. Obviously, being able to propose an alternative solution to these overmolding technologies is a real advantage.
The Sherloc QSP project has reached such a result with a strong involvement of all partners.